All right, we're going to take a look at some example problems on determining if events are independent or dependent. And at this point, hopefully you have started to realize there are a couple of words that we're going to look for as we try to determine whether we have dependence or independence. And one of the words that we always look for is whether things are done with replacement. So, replacement. Right, and what does replacement mean? Replacement just means that when I pull something out of a group, I put it back into the group. That's one of the telltale signs that something is independent. The other thing that I like to look for is I just actually take a look and see, is the outcome of one event going to have some sort of a bearing or some sort of an influence on the next event happening? So let's take a look at this first example. And the first example says that we flip a coin. Okay, so I have this little coin right here. All right, and the coin has a heads and a tails. So I'm going to flip this coin, and one of two things are going to happen, a heads or a tails. Once the coin is done flipped, I'm going to roll a fair six-sided die. So let's get to see my great artistic ability. So yeah, there's a die, and one of six things are going to happen on the die. So I'm going to get a 1, a 2, a 3, a 4, a 5, or a 6. So my question is, are these two events independent of one another? If I flip a coin and it lands on heads, does that give me an advantage when rolling the die? Like maybe I say the second event is I have to try to roll a 1. So if I flip to heads, there's a 1 in 6 chance of getting a 1. Or if I flip a tails, there's still a 1 in 6 chance of getting a 1. So these two events are what we call independent. They are independent of one another. The likelihood of one event is not going to cause the second event to change at all. So those two are independent events. Let's take a look at another example. It says a bag contains 8 red marbles and 4 blue marbles. So here we're going to draw a little picture. So we have 8 red. So 1, 2, 3, 4, 5, 6, 7, 8. And 4 in blue. Let's see how well this shows up on this background. 1, 2, 3, 4. If I change that. There. So I have 8 red marbles and I have 4 blue marbles. And it says I randomly pick a marble and then pick a second marble without returning the marbles to the bag. So this is where it's going to start getting interesting. So this is the with or without replacement. So let me highlight something here. This says without returning the marble to the bag. So that's really important. This is what we call without replacement. So this is a without replacement problem. Okay, I am not going to put them back in. Alright, so I have all these marbles. Let me see if I can ungroup these things so they move independently. Perfect. Yeah, now all my marbles are going to move independently. Okay, so it says a bag contains 8 red marbles, 4 blue marbles. I randomly pick a marble, then pick a second marble without replacement to the bag. The first marble is red and the second marble is blue. Alright, so if I pick in my first draw a red marble, I want you to think about what we have. I have 12 marbles in the bag. I don't like writing in that color. Let me change to a lighter color. Something we can see a little bit better. That's better. So I have 12 marbles in the bag. the chances of me picking out a red marble is 8 out of 12. And if I do pick a red marble out, my second draw does not have 12 marbles in it anymore. There are only 11 marbles. And the second one has to be blue, and there are 4 blue ones in the bag. So I could find that probability by taking 8 over 12 and multiplying by 4 over 11. That is if I picked a red one first. Well, if I don't pick that red marble first, let's assume that when I drew out of that bag, I did not select a red marble first. Well, then that would change the probability of getting a blue on my second draw. My second draw is still going to be out of 11, but if I accidentally draw a blue one first, the probability of drawing a blue one second would now be 3 out of 11. So you can see these two probabilities right here are not equal. It changes. So that second draw depends on what happens in my first draw. If I draw a red one, then my probability would be 4 out of 11. But if I draw a blue one, then my probability is going to be 3 out of 11. So this is a situation where my two events are dependent. Easy way to find that is when I see things that are without replacement, it is nearly always going to be dependent events. Without replacement will be dependent events. If I find it is with replacement, which we're about to see, you're going to get your independent events. Let's go on to the third example. It says a box of chocolates contains 5 milk chocolates, 5 dark chocolates, 5 white chocolates. So here we go. We have 5 milk chocolates. We have 5 dark chocolates. And we have 5 white chocolates. It says we randomly select and eat 3 chocolates. All right. So think about what is happening here. I am selecting from these chocolates, and then I am eating them. So if I'm eating them, am I replacing them into the box of chocolates? Well, if I take out a piece of chocolate and I eat it, then I'm no longer going to have 15 chocolates in the box. Right? This box right now has a total of 15 chocolates. But if I pull one out and eat it, then that box will only have 14 chocolates. So this is a problem that is without replacement. And as we know, without replacement means these events are automatically dependent. Those are going to be dependent events. It is going to depend on, the second event will depend on the success of the first event. So those are dependent events without replacement. Right here, this one says a cooler contains 10 bottles of sports drink. Okay, so so I have 4 lemon limes, 3 orange, 3 fruit punch. Those are my 10 drinks in the cooler. 3 times you randomly grab a bottle, return the bottle to the cooler. Alright, so I return the bottle to the cooler. So let me highlight this. It says right here, return the bottle to the cooler. So if I am taking the bottle out and then I'm putting it back, this is what we call with replacement. And if I am replacing the drink, I take it, I look at it, I put it back, these events will be independent events. Independent events because it is with replacement. All right, the next one says there are 8 shirts in your closet, 4 blue, 4 green. You randomly select one to wear on Monday, then a different one on Tuesday. A different one. So that means you are not going to be able to take that shirt and wear it a second time. So if I'm thinking about the shirts that I have 4 blue. That's a blue shirt, and like 4 of them, 2, 3, and 4. So I have 4 blue shirts. And then I have, 4 green shirts. And let's get, come on. 2, 3, 4. So if I say that I am going to wear a shirt, and then I have to wear a different one the next day. So let's say I pull this blue one out, and I wear it, and I have to choose something different on the next day, then this is without replacement. Means I am not putting that blue shirt that I wore back into the pool. So since it is without replacement, these events are dependent. Without replacement is dependent events. And I believe there's one more. Yep. Last problem. The 6th one says a basket contains 5 apples and 7 peaches. So that's apple. And that is peach. And let me make some copies of this. And it says that there are 5 apples. So, oh, come on. 1, 2, 3, 4. There's 5 apples. And peaches, 1, 2, 3. Maybe we need 7 of them. 4, 5, 6, 7. Okay, so it says I randomly select one piece of fruit and eat it. So think about what that is, what that entails. So I'm going to select the fruit. If I select this peach, I'm going to eat it. So that peach is gone. So it is not going back in. This is without replacement. Because when I pull that piece of fruit out and I eat it, it does not get replaced back in. And as we should know very well by now, without replacement means that the 2 events are dependent events. So I hope that helps with a little bit of practice, just seeing the with replacement versus without replacement. Sometimes it's going to say words like replacing it or putting it back in. There'll be times where, if you're dealing with a deck of cards, for example, you see that a lot of times, like if the card comes out and stays in your hand, it is not replacement. So you will have a non-replacement there. Or it may say you draw a card and then put it back in the deck, then you can see that it's with replacement. But the thing that you need to take away from this is if you have replacement, if it is replacement, then it is independent, and if there is no replacement or without replacement, then your 2 events will be dependent. I hope you guys enjoyed the video. Thanks.